Hey, thanks John and Katie. What a great intro. I'm Sam Spencer. I'm here with Noah Falk, and we're going to talk today about OpenTelemetry and .NET. So what we're going to cover is an overview of OpenTelemetry. We're going to talk about what's been added in .NET 8 around metrics, telemetry API improvements, and Noah's going to do lots of demos during this talk. So let's start with what is OpenTelemetry. Well, up till a couple of years ago, if you were going to add telemetry to your application, you would need to pick an APM vendor. APM is Application Performance Monitoring or Application Performance Management. The industry can't kind of decide what the acronym actually is. Anyway, you'd pick one of those, and they'd give you an SDK, and you would write code in your app to their specific API. The problem with that is you're then tied to that one APM vendor, and you can't change very easily. But also, it messes with the ecosystem because every library has to work with all of the APM vendors or pick one, and so you're constrained with libraries which you can use, et cetera. So the industry got together and said, what we really need is some kind of, this is an industry-wide problem, what we need is some middleware between the application and our back-end monitoring systems. And so what they came up with is OpenTelemetry. And so it is a platform-agnostic observability and telemetry platform. It's available for multiple languages. It's supported by most of the major APM vendors. It's open source via the CNCF, and it supports kind of the three pillars of telemetry, which is logs, metrics, and distributed tracing. Typically, in most languages, OpenTelemetry defines the API and applications write to that. We're a little different in .NET in that we added those APIs directly into the platform, so you can work against those platform APIs rather than OpenTelemetry, and then OpenTelemetry pulls that data. Recently, they've just signed off on a set of schema for, particularly for metrics and other data, which defines exactly how your metric data should look, so that if you're using, say, Node and C#, your metrics will coexist nicely with each other, and they'll use the same terms for the same things. And finally, there's a wire protocol, which is becoming more and more popular, and that's called OTLP. So looking at this in relation to .NET, I need to
nice looking diagram.
Mark some stuff here. We have our APIs in .NET representing those three pillars of telemetry: iLogger for logging, meter for metrics, and activity for distributed tracing. Those are then consumed by the OTel SDK, and there's then a series of exporter components that you can use to talk to different backends. So if you want to work with application insights, you'd use the Azure Monitor exporter. If you want to use OTLP, there's an explicit exporter for that. OTel has a router for OTLP called the OTel Collector. Jaeger now supports OTLP. Other tools like Zipkin has its own exporter. Prometheus has its own exporter. A thing that's a little interesting with Prometheus is most of these are push models. Prometheus is a pull model, so you actually have to define an API endpoint as part of your app for Prometheus to scrape from. And then finally, while we have these APIs in the runtime, not everything is using them yet. So we have a concept of instrumentation libraries that will pull data from other parts of the runtime using things, runtime APIs, and then feed that into OTel, actually using the meter and activity API, et cetera. So that's me giving an introduction. I'm going to pass over to Noah to show this in practice.
Yeah, demo time. Okay. So what we're going to do is we're going to do a monitoring dashboard. And we're going to use OpenTelemetry, we're going to use Prometheus and Grafana. And what we want to see is we want to see some application performance, how's app doing in production, and also if there's errors in our web requests, we want to see those too. And you can do this many ways. It doesn't have to be with Prometheus and Grafana, but we picked Prometheus and Grafana because they're free, they're open source, and they're pretty widely used in the industry. So that's a great combo. All right, so now let's check out this app. So what I've got here is my sandwich shop, and my secret goal is to make Sam as hungry as possible. And so this sandwich shop is a .NET 8 web API, and I started with a basic template, and I've only done a little bit of work. I made this orders controller and forgot to get rid of that. Orders controller, and all this thing does is it takes a user ID and a sandwich choice and a store where the user would like to pick up their sandwich, and it creates an order, and then I pretend to save it into a database, and then I send back my the new order ID. So at the moment, this app isn't producing any telemetry at all, and we're going to need to be sending some data in order for our monitoring dashboard to work. So let's hop back over to program.cs, and we're going to make that happen. And so one other thing I did beforehand is I did add a couple of NuGet packages. I added the OpenTelemetry extensions hosting package, which has most of the APIs I'm going to write to, and then the other, I added a exporter package for Prometheus, as you saw in the diagram there. So I'm not going to make you wait while I type a whole bunch. We're going to do sneaky drag and drop. So here we've got almost all the code that we need to get this working. And if you saw any of the Aspire demos yesterday, this is very similar to code that Aspire would put into the service defaults for you. But because this app isn't using Aspire yet, this is just a plain old .NET 8 Web API, we're going to add it manually. So what we're doing here, we're adding OpenTelemetry to our service container, and then we're calling this with metrics API to say that we want OpenTelemetry to send metrics. And these 3 lines right here say what kind of metrics we want to send. So metrics are divided up by meters, which are like categories with a name. And so these 2 right here, these are new meters built into .NET 8 in ASP.NET Core. And then this one here is also new in .NET 8, and this is built into HTTP client. And so together, this is like inbound traffic and outbound traffic, and this is what we're going to be taking a look at. And then we've got this Prometheus exporter, and like Sam said, this is how OpenTelemetry knows to make the data available to Prometheus. And because Prometheus uses a pull model, which is a little bit odd, we need to do one more thing down here, which is we need to add this scraping endpoint. That's where Prometheus is going to get the data from. And so, all right, last little bit. So you also see I added this OTLP exporter. And this is not needed at all for our monitoring dashboard. But the reason I stuck it in is that a while back, Sam convinced me that Aspire dashboard we've got for the telemetry, it's
pretty damn
really
cool.
Yeah. So
we're going to have worked on it.
We're going to have a little fun with that as well. And the Aspire dashboard, it uses OTLP to get the data. And so basically we pulled it out, we made it standalone. And so now it's basically like any telemetry we send out, we can take a look at it in that dashboard just to spy on what data is coming out of our application. And also not needed for the dashboard, but I put the logging here as well so we can check that out too, and we'll use it a little bit more later. OpenTelemetry does also support distributed tracing, which is also awesome, but we're not going to get to it in this demo, unfortunately. So with all that said, let's get this thing rolling. So I'm just going to run my app, and I'm going to use this .http feature here, and we're going to start making web requests. So we're going to order a grilled cheese.
You can see all the questions that have been submitted, and they'll also ask questions on your behalf. So that'll be,
we're going to order a club, and let's go ahead and then take a look at, let's go over here first. So here is that Aspire dashboard I was talking about. So here we can see the logs for our app showed up, but I want to hop over here to metrics. So here we've got those 3 meters that we turned on, and each one of them has a list of different metrics turned on by that meter. So let's take a look at HTTP server request duration. So this is showing the latency of web requests. And we can see here's some different percentiles of latency, 50, 90th, and 99th percentile shown on the chart here. And we can also see that these metrics are broken down by different dimensions. And so you can filter, for example, if you only wanted the latency of the order create endpoint, or you only wanted the latency of certain status codes, you could do that. And then we'll just take a quick peek. We can see other metrics, like here's the number of active connections to the ASP.NET Kestrel server, or here's the number, here's our outbound HTTP client requests, here's latency on those. These are some popular metrics you might be interested in. So now I'm going to take this same data and we're going to use that to power this Grafana dashboard. And so all I did to get this dashboard is our coworker James basically put this thing together, and it's hosted in our repo, and there's a link to it at the end of the deck. And I just grabbed that thing and I stuck it in Grafana. There's also a link at the deck that if you've never set up Prometheus and Grafana before, you can deploy it on your local dev machine. You can deploy it, on any machine in the cloud. And there's a link at the end that says how to set that thing up. So once you've got this, you've already got sort of a basic monitoring solution that it can at least tell you, some interesting starting point info for your app.
Yep.
And so now we're just going to dig in a little more how you can further customize.
Switching back, please. Sweet. So Noah showed metrics. What if you want to delve into more details? The way you would typically do that is with logging. And logging in .NET is exposed to a concept called iLogger. This was initially introduced by ASP.NET, but is now available in Microsoft Extensions logging for all applications. iLogger is DI-based, dependency injection, and has a source and provider model. It's a bit of a confusing nomenclature. So the source is the components that are actually going to send log messages, and the providers are the components that will receive those. Examples of providers are the console output, which you'll typically see when you're running an ASP.NET application, OpenTelemetry, of course. If you're running on Windows Server, you can send it to the Windows event log. If you're debugging, Visual Studio will hook that into the debug output window. And then you can configure, through config, you can say which sources you want to go to which provider and at which log levels. So if you want to actually send log messages, then there are a couple of different ways to do it. The simplest and dirtiest, and one that members of our team cry if you use it.
Only a little bit.
Riley. There's a set of extension methods of iLogger for log information, log warning, log error, etc. This takes a message string and parameters, but the parameters is typed as objects, so they have to get boxed. That message string has to get parsed each time, and there's no stable ID on it. So it's quick and dirty, but if you're doing anything in a high frequency application, don't use this API. Instead, there's a mechanism called loggermessage.define that will automatically create a delegate for you. And this is much better because the parameters are strongly typed, so there's no boxing required. The message only has to be parsed the first time it's created, and it has a static ID. The problem with it is it's kind of fugly. So in .NET 6, we added a code generator. So instead, what you can do is you define a partial method and decorate it or annotate it with the logger message attribute. And it will then generate pretty much the same code as loggermessage.define, but it will also automatically handle exceptions. So that is what we want you to do if you're doing logging. What we have extended that with in .NET 8 is the ability to use custom objects as part of those log messages. So in this case, I have a user info record with a name field and a GUID. If I pass that in, typically it will just go like a toString on it. But if I want the individual fields, what I can now do is decorate the logger message call with a log properties attribute, and it will go and pull each of those properties, each of the public properties off the object and include those on the log message. Akin to most of our serialization, if you don't want particular properties, you can use the log property ignore attribute to tell it to ignore specific ones. Or if you want full control, you can use the tag provider attribute to delegate the functionality to a particular method. And it can then write out whichever properties it wants in whatever format it wants. Finally, we've added IEnumerable and iDictionary support. So if you pass one of those into a log message, all the members of those will be omitted. which is great for small ones, but if you pass a large dictionary, you're going to be in trouble. All right. Finally, on logging, some really cool stuff here. We have a bunch of internal teams at Microsoft running high-performance, high-scale services, things like Office 365, Dynamics, Teams. And they typically use .NET on the back end. And so in producing those services, they have been building internal libraries of functionality that they need. And we got together with them in .NET 8 and said, well, the rest of the world wants that functionality as well. You've learned a bunch of great lessons. How can we bring that into the .NET runtime? So 3 things we brought in for logging. The first is redaction. So if you're running a global service, different regions have different rules on how to handle personal PII, personally identifiable information. Typically, you don't want that to appear in clear text in a log. Depending on the region, it might have to be removed. It could just be replaced with a kind of redacted, or it could be hashed instead. So we now added a whole policy mechanism for that, which you can use. There's enrichment. So if you want to have the same fields on every log message, for example, you want the subscriber ID, or you want to know the customer's quality of service tier, you don't want to have to pass that data all the way through the code to like deep points where you send those log messages. So instead, what you can do is do enrichment either at global scale or at the HTTP request level, and add those, and they'll get appended to every log message that gets produced. Finally, we do a lot of unit testing, and so they produced a component that acts as an iLogger provider. In your unit tests, you can call your code, it can write log messages, you pass in that fake, it will record all the messages that are output, and you can then, as part of your test, go look and ensure that you got the log messages that you were expecting. So I'm going to pass over to Noah to show us some of this in practice.
There's way too many features there. I'd never be able to demo that all in time. So we're going to do just a little bit, just a taste. So let's say we deployed our monitoring dashboard before, and now it spotted that some error was happening, but we know it's happening, but we don't yet know why. And so we decided we really need some more custom logging to be able to track that thing down. And so I'm just going to show an example quickly of how you could add some custom logging to your application. And so all we're going to do here, we're going to do the source-generated logging, like what Sam described. So I'm going to go ahead and create this. Oopsie.
Oh, that really is partial, isn't it?
Yeah, very partial. All right, so we've got this static partial class log here, and we've got one method in this class for each kind of log message that we want to send. So this one has log level information, and here's the template for it. We can see there's going to be an order, and then we can see it, it's going to take this order property. And all I want to do is I want to log all the properties on the order so that I understand what was the state of the order at the time it got created, and then if things go awry from there, I'll have this log as reference. And so I can use that cool log properties attribute that Sam just mentioned a moment ago. In the past, I would have needed to create like a giant template string and put every single property of order into the template. And if order ever changed, I would need to go back in my code and find every place that I had it and update all of them, or maybe they'd be out of sync. And this is way simpler than that. So after this, all I have to do is go to my create method where I'd like to do the log, and I'm just going to go ahead and stick this logger order created call right in there. And now let's just run this again. And now whenever I have orders, we should see log messages for it. So let's go back to try and make Sam hungry again.
I'm very hungry at this point.
Grilled cheese, order a club.
More clubs,
maybe another.
Please.
Okay, more clubs. 3 clubs. There you go. All right. And now if we go here to our structured log viewer again, we can see these new messages that were not there before, saying that our orders were created. And this would go to any telemetry backend that you had. It doesn't have to be, of course, this one. And when we go and we view, we can see that all of the different, we can see order create time, store ID, sandwich, user ID, all of the properties of the order got logged just the way we wanted them to.
Perfect.
So now let's do some metrics.
All right. Can we switch back, please? Okay, metrics. So our support for metrics in .NET is through the System Diagnostic Metrics API. From that, you can create a set of different instruments. There's counters, gauges, histograms, which is useful for tracking times. That gives you the P95. It's different latencies. There's both kind of point of time, so you just like fire values, or there's observable variants that will call you back when they wants to measure a particular value. As Noah kind of showed in the demo for the built-in metrics, you can add key value tags to those to add dimensions. These are really handy, but don't go overboard with them because it becomes each combination of key value explodes out the tracking for those metrics. And of course, these can all be observed through OpenTelemetry. Drilling into what we have in .NET 8, there's a whole set of new built-in metrics. Noah showed them. The ones we've done this release are around ASP.NET Core and HTTP Client. And these are all dimensioned. They're all built using the semantic conventions from OpenTelemetry. The developer who worked on that, James, he was adding it to ASP.NET, which is heavily based on DI, both internally and for you guys using it. And he realized that metrics doesn't kind of support DI very well. So came to us and said, like, we need a DI mechanism for defining my meters and defining my counters. So we added that. That's called iMeterFactory. We also added a fake to enable unit testing. And similarly to how with logging you can add static properties to them, you can also define static tags and dimensions for your metrics. So I'm going to pass over to Noah for the final demo.
All right. So as our last step here, my boss at the sandwich shop told me, we'll pretend, told me that we really want to track the number of orders. We want to track which sandwiches are being ordered, which stores they're being ordered from, and he wants more metrics on that dashboard. And so my job is to metrics. There's always more metrics. Everybody wants more metrics. So we're going to add some more metrics. So to start with, I have defined this class, sandwich shop metrics. And in here, I'm going to put all sorts of custom metrics for my app. But at the moment, I just have one. I have this orders counter. And all I'm going to do here is I took my meter factory as this constructor. I used the meter factory, unsurprisingly, to create a meter. And I've named my meter sandwich shop. And then I use my meter to create a counter. And so I've named this counter the sandwichshop.orders.count. And that's it for this. So now we just need to hook this up. So I'm going to hop over to Program CS here. And what we need to do, we need to create a singleton instance of our sandwich shop metrics and push that into the service container. We need to enable this meter just the same as we were for others. So let's put that there. And now the meter would, the counter would show up, but it would always be 0. We're not incrementing it yet. So let's get it incremented. So go ahead and stick that there. Yeah, good enough. And as a last step, let's add some code to increment this. So here we go. We've got the add call on the orders counter. So every time create is called, we're going to add 1 to the orders counter. And I've also defined 2 dimensions, the store and the sandwich. And now let's give this a run, check out our new metric. So last call, grilled cheese, club, and let's take a look. So here's our new sandwichshop.orders, and we can see 2 sandwiches have been ordered, just like we said. And if I get rid of grilled cheese here, now it's just 1. So there we go. Now I just go over to the dashboard, edit my Grafana, and make it look a little prettier.
Yep.
And metrics done.
Yeah, so the cool thing about that dashboard is it is dynamic, so as additional metrics are created by your application, they're automatically shown in the dashboard. You don't need to go modify it like you do with Grafana. So as you're testing your own app, it's really the great way to see what is going on with your application. All right, if we can switch over to the resources slide. Here were the links that Noah promised. And I believe we are out of time, so I will pass back to John and Katie if we have any questions.